I'm recording this in June 2026. There are so many headlines about El Nino of 2026 that my head spins, especially because on social media, uh, pretty much everybody is posting something. There's nothing wrong with it. It's just that some of the statements being made are quite horrendously wrong. So, am I recording here? Yeah, so let's start with just defining the basic state. And you can see this is from the reanalyzer.org, provides nice animations showing just surface temperatures for, you know, every year from 1979 to 2000. You see the movement of the sun, which means the entire season moves. So during boreal winter, northern hemisphere winter, warmer temperatures are to the south. As the sun moves north, we have the warm temperatures moving north, and we have, of course, cooling during boreal winter months. You can focus on one or two spots. This is getting now into summer, so you can see it gets warm, but we are more interested in El Nino, so you can look at the Western Pacific and the Indian Oceans, and you can see the Western Pacific has a warm pool which is completely to the south of the equator, almost completely, and it moves back to the north as the sun moves north. And then, of course, you have asymmetries because the ocean has boundaries, and we have trade winds here, as you know. I'm not going to go into those kind of basics, but once you have trade winds and you have Coriolis, you are going to diverge waters on the equator because trade winds are basically trying to push water mostly to the west, which means Coriolis to the north in the northern hemisphere, to the south in the southern hemisphere. So water is parting from the equator like Moses parted the seas. So you end up with cold temperatures here, which have a strong seasonal cycle. Obviously, when the trade winds are strong in June, July, August, September, upwelling gets stronger, so cold waters from below are brought up. And during the spring is when interesting things happen. The temperatures here tend to become the warmest of the year in the annual cycle. You have warm temperatures in spring in the east and coldest temperatures in, let's say, July, August, September, and you have the warm pool on the other side. Obviously, you have a flat sea surface temperature gradient in March, April, May because these temperatures get warm and these remain warm. So the east-west sea surface temperature gradient becomes very flat. Why is it important? We will see later that during an El Nino, we are actually warming this region and flattening the sea surface temperature gradient, but that kicks off a coupled feedback ocean atmosphere response. Ocean reacts to atmospheric anomalies, then atmosphere responds back to the ocean anomalies, and we have coupled feedbacks which are starting right now in 2026 June, which means the warming will get stronger and stronger till December, January, February, and then typically El Nino tends to die away. Okay, so we'll do this in little pieces, just shorts of YouTube, a few minutes videos, so that you can track and follow up on what are the basic things. Of course, associated with this are the rainfall pattern, the intertropical convergence zone, which is the pantropical rain band, which also moves north and south with the sun, but there are exceptions. It doesn't go to the south of the equator here and here, but on the other side you have the South Atlantic convergence zone, the South Pacific convergence zone, and of course the Indian Ocean is unique because you have the monsoon circulation. So you can see ITCZ is clearly to the south in the boreal winter months when the sun is to the south, but as sun moves to the north, the monsoon produces upwelling and cold temperatures here, but it produces, still has warm temperatures. So you have the marine ITCZ ITCZ remaining here throughout the year gets, changes in its extent, but we also get the monsoon. So we get Western Ghats, Himalayan foothills, Bay of Bengal, core monsoon zone. So this is what we call the continental tropical CTZ, continental tropical zone, as opposed to intertropical convergence zone. So monsoon is very unique, but you can pay attention to this large heating that happens here. About 5 meters of rain falls here in a year, and basically you all know that during El Nino this tends to shift eastward on average, which means you're going to have less rain here, and this is the basic state of the tropical Pacific. Warm temperatures, warm pool, cold temperatures, upwelling, ITCZ, and we'll see that during the ENSO events, El Nino events, ITCZ moves south as usual, and the warm pool area convection moves east. So south ITCZ, west east convection. So lots of things happen when you move such a big heat source. You're going to perturb global weather, which is what we call teleconnections of El Nino. Okay, so we will stop here and come back and continue. As I said, I'll keep doing this in little pieces. This is about 6 minutes. I will try to keep it to about 5 minutes in general anyways. Okay.